Alright guys, we are going to pick up where we left off. So we are on, what page are we on? 59. And we got one more example for a confidence interval for proportion. We'll finish that up and then move on to the next chapter. So we have a Gallup poll, 595 of the 1,009 adults surveyed said they wanted to lose weight. And we want to know the percentage of the sample that wanted to lose weight. So we calculate the sample proportion. That would be p hat. That's pretty straightforward. That's equal to 595 divided by 1,009. And that's equal to 0.590. So around 59% surveyed, 59% of the people surveyed wanted to lose weight. Next question, find a confidence interval for the proportion of people in the population that wanted to lose weight. So the 95% confidence interval, again, we're just going to use the formula up here on page 55. And 95% corresponds to a z-value of 1.96. So we're going to use this formula and put 1.96 into the formula there. Q hat is just 1 minus p hat. So 1 minus 0.590. That would be 0.41. All right, so our confidence interval then is 0.59 plus or minus 1.96 times the square root of 0.59 times 0.41, which is just 1 minus 0.59, divided by 1,009. So crunching those numbers gives us a lower bound of 0.56 and an upper bound of 0.62. So we are 95% confident that between 56% and 62% of adults want to lose weight. The sample proportion was 59%. That was in the Gallup poll, but we want to extend this to the population, which is adults or all adults. So I can interpret that confidence interval. So we are 95% confident that between 56% and 62% of all adults want to lose weight. Sorry. All right, so that's the interpretation. I usually change it to percent when I interpret it. And then the last question for the chapter, suppose a nutritionist claims that 73% of adults want to lose weight. Is his number plausible based on the confidence interval? So based on the confidence interval, we said it's between 56% and 62%. And so based on the confidence interval, it's not. %, would be too high for the percent of adults who want to lose weight. All right, and I'll just show you on the calculator real quick. If you use the calculator, we're always going to be going to stat now and then test. Then you, for a confidence interval for the mean, you scroll down to letter A. So 1 prop z interval. Prop means proportion. Z is because we're using the normal curve, and interval. Okay, and so I want to enter my count. My count was 595. My sample size was 1,009. And my confidence level was 95. and then I just hit enter. Or yeah, enter. And I hit it again. There we go. So we have about the same numbers, a little bit of rounding error, but 0.56 up to 62% when we use the calculator. Okay, so that's it for that section. The next section is very similar. We're going to do confidence intervals again, but now we're doing confidence intervals for the mean. So for the rest of the semester, it's really important that you recognize when we're calculating a mean versus a proportion. The mean is for quantitative variables, so measurements like height or weight, whereas a proportion is summarizing a categorical variable. So the proportion of individuals who wanted to lose weight, that was a categorical question, yes or no, and we summarized it with a proportion. So the next couple of questions just ask you whether you would use a proportion or the mean. And that depends on whether it's a quantitative variable or a categorical variable. So we have a random sample of 2,613 adults were asked whether they had voted in the election. 1,783 said yes. And so this is a categorical variable. And then the parameter, I'm going to write the parameter out here. So this would be a proportion that we'd want to estimate. So we would use the methods that we used in the previous section. The next one says a researcher was interested in whether or not the advertised weight of a candy bar is accurate. The student sampled 30 candy bars and recorded the weight. So that's a quantitative variable. And for that, we would use the section that we're going over now because we want to estimate the mean of the weights. And so the parameter would be mu for mean. Sorry, that's pretty sloppy, but that's mu, the Greek letter mu. And that's what we're going to try to estimate in this section. A researcher interviewed 100 customers at the local bar and asked them whether they smoke cigarettes when they drink. This is a categorical variable, so we would use the methods in the previous section since we would summarize it with proportion. The next one, she was asked how many hours of sleep. So that's a measurement, that's a quantitative variable. And we would summarize that with a mean. And so we would be trying to estimate mu, the Greek letter mu, which means mean. Okay, so now we're going to just extend the last section to same idea, but with we're trying to estimate the mean of something rather than the proportion. We're still going to use confidence interval, but our formula is going to change a little bit because we're no longer sampling or calculating a proportion. So we still have a margin of error. So this is the formula for the margin of error. This is actually a mistake. That should be the letter S. So go ahead and fix that on your notes. And now we're using values from the t-distribution, and I'll show you that in a second. And then we're also going to be calculating a confidence interval, which is x bar plus or minus the margin of error. Same thing as up here. So this is really just x bar plus or minus the margin of error. Again, this actually should be S. So go ahead and fix that. That's the sample standard deviation. And the t-distribution is what we're going to use for the critical value for these formulas. So you have the t-distribution in your notes in your course packet. It's the page right after the normal distribution, and it looks something like this. And we're going to use these values down here to look up the critical value for the confidence interval. That's the value for t. And what we're going to do is, if we need a 95% confidence interval, let's say we would come over here to 95%, and then we would scroll up to our sample size minus 1. So if, let's say we had a sample size of 30, we would, in a 95% confidence interval, we would scroll up to row 29, which is right here. And so our value for that, for our t-distribution would be 2.045. This would be for 95% and a sample size of 30, you subtract 1, so you would go to row 29. All right, and so interpreting a confidence interval, we do that the same way as for proportion, but we want to make sure we include the word mean or average in our interpretation, because now we're interpreting, now we're trying to estimate a mean or average. So here's an example. We are 95% confident that the college students study on average between 1.5 and 5 hours a week. So you definitely want the word average in your interpretation. All right, so I think the next video will just pick up where we left off. I'll see you later.